I hope everyone's having a great evening, and thank you for joining me for this video. What is the real reaction and what is it that we're talking about? Well, we're looking here at sodium solid, which is sodium metal, which is going to be placed in water. Sodium has a violent reaction when it's placed in water because of the nature of sodium. Sodium has 11 electrons. It has an atomic number of 11. So you're looking at 1s2, 2s2, 2p6, which basically represents a neon configuration. Then you have this 3s1. This 3s1, the valence electron is very easily lost, hence explaining the very high reactivity of sodium. It's so reactive that you won't really find it pure in nature. It'll always be some form of a metal oxide or combined with some other item simply because it's that reactive. What would happen if you were to place sodium in water? You would have a violent reaction. You have hydrogen gas generated and you'd have sodium hydroxide aqueous, which would be generated a base. But that right there is just the generalized reaction of what's going on. It doesn't give you a true idea of what's really going on. We have to determine what the real underlying reaction is, and it's an important exercise to embark on. So let's see what we're looking at here. Look at the oxidation states. When you're looking at this, you're looking at a 0. Here you have a -2. Each of the hydrogens are +1. Here you have a 0. You have a -2 for oxygen, +1 for hydrogen, +1 for sodium. The changes that you see are this. For sodium, you're going from a 0 up to a +1. Oxygen stays the same, but for hydrogen, you're looking here from a +1 to a 0. So you're seeing sodium is basically oxidized and hydrogen is reduced. So the underlying reaction must not be what you have on the top. It must be a redox reaction. Notice this is unbalanced, but you could easily balance it by just putting these coefficients 2, 2, 1, 2, and that's your balanced reaction. But again, we have to find the underlying reaction, and we will, now that we know we have an oxidation reduction reaction. Sodium is oxidized, hydrogen is reduced. So let's bring that into perspective. What will my half reactions be? For sodium, it's going to be this. It's going from sodium to sodium ion plus 1 electron. Hydrogen, you have something like this, and then electron to give you H2. But you gotta balance it by bringing in these. But then you must balance the charge by bringing in a 2. When you look at all of this, you know this will cancel out with this. Your net reaction will really end up being 2 sodiums, because this 2 will multiply across, plus 2 hydrogen ions, and then you'll have 2 sodium cations, and then we'll have H2. You know this here is going to be a solid, this here will be an aqueous, this here will be aqueous, and here this will be a gas. But this cannot be your actual reaction, because look, you're generating a base, and then here you're looking at a acid or a proton species. Therefore you must accommodate this redox reaction and balance it for a basic solution that will generate. And you can easily do that. If you were to add 2 hydroxyls on this side, and you would bring 2 hydroxyls here simply to maintain the balance, you can combine these two. This will give you your 2H2O liquid, and then you'll have this 2 sodium solid, and then you'll have this 2 sodium ion aqueous plus H2, which would be a gas, plus 2OH minus, which would be your aqueous species. And now this right here would be your true reaction, the true redox reaction, which represents what happens when you put sodium metal in water. This is it. Everything should be balanced. You have 0 charge here, you have +2, -2, it's zeroed out, which is good. You have 4 hydrogens, you have 2 oxygens, 2 oxygens, 2 sodiums, 2 sodiums, so everything is good. If someone were to ask you what's the underlying reaction which is going on, it's this redox reaction balanced in a basic solution, and that's your answer. Thank you for watching this video. Have a good day.